Assalamu alaikum. So today we're going to keep working on Calculus 1 General Review. So let's start with this set of questions. So here they ask us to use the method of calculus to find out the exact limit. So if it does not exist, we just need to justify our answer why it does not exist. So we'll start with the first question. So we have limit when x goes to 0 of cosine 6x over cotangent 7x. So here if I substitute the 0 here, I will have cosine of 0 over cotangent of 0. So we know that cotangent of 0 is undefined, but cosine of 0 is 1. So what I need to do here, I need to see what to make it defined. So, and this is very simple, so I don't need to change cotangent to sine or to cosine over sine. What I need to do, change cotangent to tangent. So we know that 1 over cotangent is equal to tangent. So this, the limit when x goes to 0 of cosine 6x over cotangent 7x, in fact is the same thing as the limit when x goes to 0. So 1 over cotangent will become tangent. So let me write it down in different way. So cosine 6x times 1 over cotangent 7x. This is exactly how we deal with the fraction. So it is the numerator times 1 over the denominator. So now this is my tangent. So this will be my limit, cosine 6x times tangent 7x when x go to 0. Now we know that cosine of 0 is 1 times tangent of 0 is 0, so the limit will be 0. So the limit of 6x cosine 6x over cotangent 7x over cotangent 7x when x go to 0 is 0. For number B, this is A. For B, here if I apply the limit, normally I should have, I think, 0 over 0. So then we can use Lhopital rule. It's more easier here, because if I don't use Lhopital rule here, I will have a long answer. So because I need to deal with long factoring. So when I apply 1 here, I got 1 minus k plus k minus 1 over 1 minus 1 square, and as you see here, this is 0 and this is 0. So now what we deal with Lhopital rule. So what I do, I take derivative of the numerator and take the derivative of the denominator. So this will be the same thing as the limit of kx k minus 1 minus k. This is just constant, so it equals 0, and the same thing here. And here we have 2 times x minus 1, the derivative of x minus 1 square. So when x goes to 1, again here I will have k minus k, so which is 0 over 2 times 0, which is 0, so I have 0 over 0. Again, I need to deal with Lhopital rule, so I'm going to do Lhopital rule here. So I did the Lhopital rule the first time, now I'm going to do Lhopital rule the second time. So I will have the limit when x go to 1. Here is going to be k times k minus 1 x k minus 2 over the derivative of here is just 2. So when I apply x equal 1, I will end up having k times k minus 1 over 2. If you will try to factor, it's going to be pretty long and it's really ugly. So try to use Lhopital rule for that type of question. Alright, last question here. So if I have limit of 1 over x to the power x when x goes to 0 positive. So here try please to use that transformation. So if I have f to the power other function is e to the exponent ln of the base, which is e g ln of f. always use that idea. In that case, you're gonna deal only with this type when we deal with the limit. So here is the same thing as the limit when x go to 0 plus, so it's going to be e to the x ln of 1 over x. Now if I apply the limit here, I will have here 0, and ln of 1 over x is going to be 1 over infinite, so 1 over 0 plus is 1 over infinite, and of infinite is infinite, so I have 0 times infinite. So when we have 0 times infinite, so again is another way how to deal with Lhopital rule. So here I'm going to use Lhopital rule, but I need to do some transformation. So here is the same thing as the limit when x, so here like I say, let me plug the limit here. So I will have e to the 0 to 0 plus ln of 1 over 0 plus, which is going to be the same thing as e to the 0 times ln of infinite, and ln of infinite is just infinite, so it's going to be 0 times infinite. And again, you see here, this is the case of Lhopital rule, so we need to apply Lhopital rule here. So but here I need to transform this. This means this variable should be the same thing as the inside variable, that's mean 1 over x. So I'm going to transform this one to 1 over x. Now in that case I will have infinite over infinite, so in that case I can take the derivative. So first thing what we do, we change this x to 1 over x, so this is become ln e to the ln of 1 over x divided by 1 over x. And keep in mind here we didn't do nothing, because look, if I have a over a fraction, b over c, it's like you flip it, so it's the same thing as a times c over b. It's exactly what we did. So here we have, let me show you the idea here. Here what do we have? We have x ln of 1 over x, which is the same thing as x over 1 ln of 1 over x. So what I do, this is the denominator of ln is 1. I just move this one down, but in order for me to move it down I need to flip it. You see, when we change the position of a number in the fraction, we flip that number. So here I want to change it from the numerator to the denominator, so I'm going to flip it, so it's going to be ln 1 over x over 1 over x. If I want to return it back, what I do, I flip the denominator, so it's become x over 1, so we'll end up having this. So that's the idea behind. Alright, so here after I flip here, when I apply the limit, I will have infinite over infinite, because 1 over 0 plus is infinite. So here what I do, I apply the Lhopital rule, so x go to 0 plus. So here I will have e, and ln 1 over 0 plus is infinite, which is what we got here, so it's going to be infinite over infinite. So in that case now, it's one of the case when we deal with Lhopital rule. So I do the Lhopital rule here by taking the derivative of the numerator and the denominator. So we'll have the limit of e to the derivative of ln is the derivative of the inside over the inside. So let me write it down here. Ln of something prime is the derivative of this thing over the same thing. So here I will have the derivative of ln, which is 1 over x prime over 1 over x, divided here by 1 over x prime, which is going to be minus 1 over x squared when x go to 0. So all this is on the exponent of e. So if I want to do it in big E, so it's going to be like this. Okay, so all of this is on the exponent. So this is prime, so it's going to be minus 1 over x squared, so it's going to be the limit of a big E of minus 1 over x squared, the whole thing over 1 over x, divided by minus 1 over x squared. So here I need to play with the simplification here. So here I will simplify the top, so it's going to be just minus 1 over x, so it's going to be here the limit of the big E of minus 1 over x divided by minus 1 over x squared when x go to 0. Again, I will flip this up, so it's going to be the limit of minus x squared over x, which is going to be e to the plus x when x go to 0. So when I plug in 0 here, I will end up having e to the 0, which is 1. So I hope this is clear. Alright, next question. So here we have a word problem. So local farm is constructing a 500 square foot rectangular pen to hold horses and cows. One side of the pen will be along the barn. So here let me draw. I like to draw every word problem, so I need to draw that one. So this is my barn and this is my land that has 500 foot square. Alright, there will be also need to be a land fence divided pen. Okay, so I have another one here. Alright, depending to two component perpendicular to the barn. Alright, so here then what I do here, this is going to be my width x, and my length will be y, which is going to be 2y. Alright, so what should the pen's dimension to be minimize the length of the fence? Alright, so here they want to find out the dimension of this in order for us to minimize the length of the fencing. Okay, to minimize the length of the fencing, that means we minimize the perimeter function. So here we're gonna find out the perimeter of this surface. So here we know that the perimeter here is the sum of the side, the sum of all the sides. So I have x, 3x, y, 2y. So we don't have no fence here, so we're not gonna count the barn. So my function here will be b equal 3x plus 2y. So the only relationship between x and y is that we have the area. Here the area we have x, the width is x, and the length is 2y, so times 2y equal 500, which means that 2y will be 500 over x. Now if I substitute this one here, my function in terms of x will be 3x plus 500 over x. So this will be my function to optimize. So this is optimization problem, so we need to find out which one give me the minimum. So here my graph for the first question draw. So this is my graph. Write the single function. So this is my single function. Give the domain of this function. So I'm going to find out the domain. Of course it's not going to be 0 because we cannot have 0 length here, and of course it's not going to be 1, 2 or 3, but we deal with the 0. So here the domain will be 0, go from 0, it's not include, and you see I need to make sure that cannot go beyond the area. So if I put x equal 500, then I will have to y will be 1. I can have feet of y, but most of the time we don't deal with that, so we divide by 2. Keep in mind that the width of the horse is not like 2 or 3 feet. So, but we deal only with the 2 here, so that means the maximum is going to be 250. Not to include because it's almost less than 250. But this will be my domain, which is going to work for y and x. Alright, for at what value does the function take a minimum? So here I need to take the derivative. When they ask for minimum, maximum is the derivative. So p prime x, so it's going to be 3 minus 500 over x square. Now because I'm looking for the minimum, what I do, I make it equal to 0. So p prime of x will be equal 0, which means that 3 minus 500 over x squared equals 0. So 3 equal 500 over x squared, cross multiply, so I get my x squared equal 500 over 3. Take the square root, so x will be square root of 500 over 3. Pull out 100 out, so it's going to be just 10, so which is going to be 10 square root of 5 over 3. So this will be my x, which is my width, and just substitute here to get the y. Now is this the minimum value? Alright, let's check. let's do the line of sign. So here is my 0 goes the minimum, and here we have 10 square root of 5 over 3. So if I pick a number less than 10, for example 5, pick 5 and see what you get here. If I pick 5 here, I get 25. 500 divided by 25 is 20. So 3 minus 20 is negative. That means the side will be negative and here will be positive. So which means decrease and increase. That means this, you see, is the minimum. So this value is the minimum they look for. Alright, so next question here, find the derivative of the following function. So do not simplify. So for the first question, this is quotient rule. So we have y equal tangent of x over x. So I'm going to use quotient rule. What does the quotient rule state? Is f over g prime is f prime g minus f g prime over g square. So here y prime will be tangent x prime times x minus tangent x times x prime. With the 1 minus 1, which is minus half. Now I simplify, so y prime will be 2x square root of x plus 1 plus, and here is going to be x squared over 2 square root of x plus 1. So they don't ask me to simplify, so I will leave it like it is. If they ask me to simplify, so I will make I will multiply both sides by the denominator in order for me not to have square root on the denominator. Alright, next question here. So here it's straightforward. So we have y is x4 plus x to the minus 2. So don't deal with it as a fraction. Change it to make it like exponent and use a regular derivative. So y prime will be 4x cubed minus 2x minus 3. Then simplify it or write it nicely. So 2 over x cubed with positive exponent. Alright, for next one here, so here again I'm going to use this idea like I told you before. If I have f to the exponent of function, so I will change it to e f at g ln of f, and we know how to deal with this because this is product rule in terms of derivative. So here y equal sine x to the exponent x squared is the same thing as e to the x squared ln of sine x, and we know that the derivative of exponential function prime is the derivative of the exponent times the exponent function. So in fact it's like I'm doing derivative of the exponent times the function itself. So we have here y prime will be x square ln of sine x prime times e to the x square ln of sine x, which is I will write as this form again. Now here I'm going to use product rule. So we know that ln derivative is ln of something prime is the derivative of that thing over the same thing. So here we have y prime. This is product rule, so we already know how to deal with product rule. If you want me, I can put it here. Is f prime g plus f g prime. So this is my f, this is my g. So it's going to be 2x ln of sine x plus and x squared times derivative of ln, which is derivative of sine, which is cosine. So it's going to be cosine x over sine x times my function, which is this are the same, so I'm just writing it down into the origin form. Sine x x square. Can I simplify here? I don't think so. So I will leave it like this. So it's going to be 2x ln of sine x plus x squared cosine of x, the whole thing over sine, times sine x to the power or exponent x squared. Next question. So here is derivative using exponential and secant. So we know the derivative of secant is secant 10. So here we have y equal e to the cosine of x plus secant x squared over 2. So the derivative of e again is the derivative of the exponent times e, and derivative of secant is derivative of the inside times secant the inside tangent the inside is secant 10. Alright, so this is straightforward. So y prime will be here is cosine x prime e to the cosine plus here we have x over 2 over 2 x squared over 2 prime times secant x squared over 2 tangent x squared over 2. You see, it's very simple. Derivative of cosine, I'm going to remind you, so that the circle, try to not memorize, just know the circle, because most of the students know the circle, most of them. So this is my sine, cosine, negative sine, negative cosine. So derivative of sine is cosine. This is a derivative. Clockwise derivative. Counterclockwise is integral. So derivative of cosine, negative sine, and so on. So if I want to use the opposite direction, so this is integral. So the antiderivative of negative sine is cosine, cosine is sine, sine is negative cosine is negative sine. So that's the idea. Here, derivative of cosine, because its derivative cosine is negative sine, so it's going to be minus sine of x e to the cosine of x, and here will be 2x over 2 secant x squared over 2 tangent x squared over 2. So here we simplify, so it's going to be a minus sine of x e to the cosine of x plus x secant x squared over 2 tangent x squared over 2, and this will be my answer for the last question for today. So this is straightforward. Alright, so here they ask me to take derivative of this. So we have y is the integral of 3x cubed e t cubed dt. So when we have this type of question, so keep in mind, so it's like me doing the chain rule. This is the inside function and this is my outside function. So in general, so if I have y is, for example, if I have two function h of x and g of x, and here we have f of t dt. If that's me to take the derivative of this, so this is how I deal with it. It's going to be y prime equal, so the top one, which is g prime of x, f of g of x, minus h prime of x times f of h of x. So this is exactly how we should deal with it. If you have a constant here, for example 2 or 3, like our case here, you see this will be 0, it will cancel out, so it's left only that one. So here my g of x is x cubed. So if I want to integrate, if I want to take the derivative of this, so this is a constant, so if I take 3 constant, if I get, okay, let me do it here, it's, you will understand, I will write it down here. So this is my g of x, and this is my h of x, and this is my f of t. So this is my f of t. So if I want to take the derivative of this, I will have y prime equal g of x, which is x cubed prime, f of x cubed, so it's going to be e x cubed cube, because my t is x cubed, so it's going to be e x cubed cube. So I got my first part, because this is f of g, so it's going to be f of t, so here it's going to be f of t, f of x cubed, so we change the t by x cubed, so it's going to be x cubed cube, minus, and I will have 3 prime f, which is e to the 3 cube, because here my t will be equal to 3. We know that this is a constant, so it's 0, so we don't deal with it. So my answer will be y prime, this is the derivative is 3x squared, and x cubed cube, you multiply the exponent, so it's going to be e to the x9, and this will be your final answer. So I hope you got the idea here. So see you for the next part of this Calculus 1 General review. Thank you for watching the video, and please, if you have any comments, do so, it will help me a lot. Thank you very much. Assalamu alaikum.